Hello everybody, my name is Christina Davidson, and today I'm giving a presentation for a machine learning class that I took this fall. And the topic that I'm going to be going over today is if hypoxic environments and varying altitudes can affect oxidized lipid concentrations. So a little bit of background on this project is that there was several participants that were placed into a hypoxic chamber where specific altitudes and oxygen concentrations could be varied. And then various measurements were conducted from these participants. And some of these measurements included like cognitive function. They measured lipids, they did proteomics, metabolomics, and a couple other measurements. But this talk today, I'm just going to be focusing on the lipids portion, and specifically within the oxidized lipids, because oxidized lipids deal with, they contain oxygen or are involved in oxygenation processes. So that's important in hypoxic environments, so that's the specific target here. So a little bit of an outline. I'm going to go over a couple of choices that I made with data cleaning, and then run through a couple of unsupervised methods that I used to look to see if there was any grouping in the data, and then run through some supervised learning, so random forest, and then some conclusions and future directions of where I'm hoping to go after this. Okay, so a little bit about the data cleaning. The measurements were done pre and post of being in this chamber for a certain amount of time, and the post measurements were divided by the pre-measurements to account like for the same person be getting the measurement pre and post to kind of deal with the variability between people. I also chose to remove a couple missing values, so there were some measurements that were missing either the pre or post measurement. And it didn't seem that there was a way we could go back and retrieve those values. So without being able to treat those values the same as the other ones, those were just removed. Or if they were missing, missing a time point for a specific a lipid, that was also removed. That whole person was removed. Additionally, there were a decent amount of outliers in this data set. So I looked at those to make sure, there wasn't a mistake made in like writing down the value, or a mistake in data transfer, anything like that. But I did not choose to remove any of the outliers due to this being a small sample size. So I didn't feel comfortable enough that I could remove the outliers and assume that they were actually outliers, as opposed to the reason that they're probably just it's additional portion of the overall population distribution that we're just not getting an abundance of. So my guess is that they probably weren't real outliers, so it's probably some biology that's actually being explained by those, so that's why they were kept in this data set. Additionally, all of the data points were normalized to internal standards, and then, like I kind of mentioned, the variables or features that I will be working with in this data set are just specific lipids that are defined as oxidized lipids. And lastly, there were some participants that did not have a measurement at all three altitude levels, but it was decided that they would stay in the data just because, like I said, it was already a really small data set, so they could potentially have just two of the data points, and if we looked at differences between those two specific altitude levels, maybe we could see something there, as opposed to just deleting those measurements completely. So moving forward, I started with just a PCA of the lipids by altitude. So as we can see here, there's 3 different altitude levels, and we have the points colored. So there, and we're plotting here PC1 versus PC2. It's pretty common with principal component analysis. And from this plot here, we're not really getting a whole lot. There's a pretty big cluster of all 3 levels in the middle here. Maybe some potential ground level points here that could be of interest. These could be either irregular points or They could be, the typical, what we would expect to see. We're just not getting enough points to kind of really tease out the information there. There is, however, a decent amount of variability that is kept within the first two principal components, which is good. So moving forward, I added on the ellipses here, so again we can kind of confirm that we're not seeing much difference or any difference here between the three groups. So these are the 95% confidence ellipses, and as we can see, they're all three overlapping quite a bit, so it's pretty confident here to say that there's not a difference between the three levels. Okay, so next I looked at just 0 or ground level altitude versus 8,000 altitude, which was the highest that was measured here. In the instance that potentially, that middle altitude 4K, we just weren't seeing enough of the change. So this was kind of looking at the two opposite extremes to see if maybe we could tease out a difference between the two groups. So again, we're getting a really good variability that's explained. We're getting close to 70% here, which is pretty good. And although that there's quite a bit of middle clustering here where the two groups are kind of close together, there may potentially be some separation. So if we were to draw like a line, this black line here, anything that's below it is guaranteed to be ground level, and anything above it is most likely going to be 8K. So again, not perfect separation here, but we can start to tease out maybe potential instances or potential differences that we could see if we were to get more samples, or if we were to do some other transformations or something like that. So from this plot here, I decided to look into the original variable loadings. So that's looking at the original oxidized lipids. So the first column corresponds to the specific lipid that we're looking at, and then the middle column is the loading for principal component 1. The second column is for the loading for principal component 2, and anything that was included in this table here was identified as being greater than or equal to 0.7 in either principal component 1 or principal component 2. So that 0.7 was defined based on looking at all of the variable loadings and defining a subset that would be potentially significant in this case. So going from the original subset of features to the smaller subset of significant features, it decreases the overall feature number by about 50%. So if we look at that and then rerun the PCA, can we get as much information? Is it a better separation? And just kind of look to see whether these variables really are driving a majority of the separation between the two groups. So looking at this next plot, like I mentioned, so this is the separation of the 0K and the 8K based on just those subset of features. So it does increase the variability a little bit, but again, we're not really getting great separation here. We've got a pretty good mix. We might be able to tease out maybe this little group here of just 8K. And then obviously these two over here are pretty separate, but not a whole lot of added information there. So this next plot is looking at a log2 fold change. So the way that works is you would take like the ground level versus 4,000 feet altitude, and you would take the fold change of those, which looks at like an overall difference between like the ground level value and the 4K value. So it's not just a straight ratio, but it's more of like a fold of how many times it got bigger. So if you were looking from like 20 to 80, that would be 4 times, so that would be a fold of 4. And then it takes the log 2 of that. So this is kind of a transformation that's often used for metabolomic data, lipids, proteomics, different things like that, to kind of look at potential changes within that same subject from different altitude levels. So this one, again, isn't perfect, but we're starting to see some of those same trends where we have, maybe this circle here of 0 to 8K points. And then we've got maybe a cluster over here of just the 0 to 4K. So potentially, getting some good information here of difference that we're seeing between going from 0 to 4 and then 0 to 8. And again, we're getting a good amount of variability in the first two principal components, which is good. So this next plot is looking at the tSNE, which we learned a little bit about. And this is back to that first PCA that I showed of the 3 different levels. And this doesn't really look that promising at all. There's maybe some small groups like these greens up here, but everything kind of looks pretty intermixed between the 3 altitude levels here. So next, I decided to look at k-means, and I decided to start with a k equals 3. For obvious reasons, there were 3 different altitude levels, so see if we can capture 3 different clusters in the data. So as we can see here, we do have one cluster that separates from the other 2, but there's only 2 points in it, which none of the 3 groups I started with only had 2 points. They all had around 7 to 9 points. And then cluster 2 and 3 overlap quite a bit. So not really good results here. And as we can see from the confusion matrix up here, it's not doing a very good job at estimating what groups things are in. So it does, the 2 that are in group 1 are actually group 1s. So those were the 2 outliers that we were seeing within the PCA data. Those 2 red points that were often up to the top left. So it is accurately getting those, but other than that, it is not getting any of the other points that correspond to ground level here. So from this data, I decided to move to k equals 2 because one cluster had so few points that it couldn't even make an ellipse. There was only 2 points there. So potentially maybe it only needs 2. And thinking that through, that could correspond to ground level in some altitude. So maybe 4K and 8K group together and become one altitude ellipse, and then ground level would hopefully, cluster on its own and be like the no altitude group. So as we can see from this next plot, that does not happen. We're getting, quite a bit of overlap here. And you can also see from the confusion matrix and really low recall and precision that this is not doing very well at estimating the data. So this next plot is looking at the actual all values for all of the patients. So it's averaging all the patients together to create box plots at all of the lipids that we were looking at. So as you can see, there's a little bit of difference potentially between the 0K and the 8K. And also I want to note that the y-axis here is a log 2 axis. So the little changes are actually a little bit more than they may seem. And like I was mentioning in the beginning about outliers, we can start to see from this plot there's quite a bit of outliers that are happening in all of the different lipids here. But as you can see, that would be quite a bit of observations that we were removing. And when we already have such a small data set and we can't confirm or deny whether those are real biology that's happening or if they really are some strange outlier that's not what we expect. We're just not sampling enough here, so we just can't say, these are weird points or whether those are the points that we actually should be interested in. So no outliers were removed in this case. But we can start to see, so the top row up here, it either says NS or it has 1 to 3 asterisks. So the asterisk symbolizes there is significance there, and the number of asterisks means like how significant it is, so it's like different levels of significance. So we can see that there are 2 lipids here that are actually showing significance, whereas a majority are not. But these could potentially be, lipids of interest that we want to look at further. But they could be, kind of hidden from all of the non-significant lipids. So we didn't really see a huge difference in the 2 groups from the unsupervised methods that we were looking at previously. But these 2 potential lipids may be worth investigating further, to see what pathways they correspond to, or if, it really is a lipid of interest and, something that we should be investigating further, or if it's just, something of noise or something, strange that happened, or there just weren't enough measurements, what have you. So definitely something worth looking into further. So next, I decided to run a random forest on the data, and I did the random forest using the full lipid data set. So it had all 3 levels of altitude, even though we were starting to see a little bit better separation between just the extremes, the 0 and the 8K. I decided to look to see if the random forest could, maybe tease out that 3rd group, maybe see things that the unsupervised just weren't picking up. Unfortunately, not that good performance was seen in the random forest, and this is likely due to low participant number. So again, such a low sample size was done here, and especially because there were quite a few features that were measured. So could potentially be overfit issues, just not enough data to kind of tease out those differences here. In the training and testing was broken down into a 70-30, and kind of another issue that might have caused low performance was I also ran a logistic regression model, and I didn't show it here just because it didn't really show promising results. It suggested that there was probably a lot of collinearity shown in these features, so probably a lot of the features related to each other and caused correlated results. And again, kind of the reason for running this was to hopefully see some separation that we weren't finding in the unsupervised methods. So some of the results that were done here. So this first one is doing the full data, so the 3 levels of altitude here, and we can see the confusion matrix up here. So not super good, but again, we're only getting 9 subjects, and because of the repeated measures at varying altitudes, the total N was 23, and we also had 23 features or lipids that we were measuring. So as we can see here, it's not really doing a very good job predicting, and this probably should have been rerun because there were not any oh no, never mind. I was reading this incorrectly. I was going to say that there weren't any actual 4K, but that was just that there were no 4K predicted. So the model's not doing a very good job at feeling comfortable predicting people at that middle altitude. So there really just seems to be maybe a slight separation between ground level and then the extreme 8K altitude. And so the nice thing with random forest is that we can get a variable importance of the original variables to see how well they're causing this prediction. So there were 8 variables here, and the reason it was kind of cut off after this 8th variable is the next one in the percentage MSE was quite a bit lower than this, so there was a pretty good differentiation between this 0.5 and I think the next one was like around 0.1, I think. Whereas you can see the rest of these, there's a pretty good separation between X4 and X5 where it goes from about 1 to 0.6. But besides that, most like this one goes from 0.6 to 0.58 to 0.54 to 0.53. So those are relatively close together. But after this 0.53, it decreased significantly. So then the next one is looking at just ground level versus 8K altitude. and getting a little bit better performance there, but still not anything to brag about here, with a 0.67 recall and 0.5 precision. So not, again, nothing to brag about here. And the same separation was done, 70% training, 30% testing. And this one had an even smaller N, obviously, because we were taking out one of the altitude levels. So it only had 17 total N, and still looking at 23 features or 23 lipids. And so the same thing was done with the variable importance here. This one cuts off at 0.85, but again, it was another significant gap that I made the decision to kind of cut off, as these were the top performing variables. I think the next one was around like 0.3 or 0.2. So to kind of wrap all of this up, some final thoughts and potential future directions. A big issue here was there was a decent number of missing participants. So we had a lot of participants that we only had like 1 or 2 altitude values for. So it's hard to look at like their changes. So like that log2 fold change PCA plot. I would have loved to do more with that, but there was a decent number of participants that fell out because they didn't have, corresponding values at the other altitude levels. And I keep mentioning this, you're probably getting tired of it, but again, such a small N was used here, and not large, but a larger number of features. So that can kind of cause issues, but that's a lot of the problems that we kind of run into with biological data sets and biological sampling. And I mentioned this a little bit earlier, but I did also try logistic regression just because we were looking at a binary output. So with that one, I just looked at no altitude versus altitude. And I also looked at just 0 versus 8. And with both cases, it was showing that there was a high probability of correlated features. So it wasn't really giving me results that were valuable or that I could use and feel comfortable about presenting. So that was admitted, but I felt like it should be mentioned. That was something that I looked into to see if, the data fit a logistic regression relatively well or not. So additionally, moving forward, like I mentioned in the beginning, there were several different data streams that were coming from this project. So there were other things like metabolomics, proteomics. There was a little bit of demographic information, and I feel like moving forward, adding in those other data streams or looking at those data streams separately, like I did here with the lipids, would probably add valued input. So it could show, similar results that maybe our best separation chances looking at ground level versus 8K, or looking at, the fold change between 0 to 8, or the fold change to 0 to 4, and hopefully adding in additional information. Kind of another thought here is lipids could be a little bit slower. So if we think about, overall biological processes, your overall like lipid concentrations are probably going to be a little bit slower to show changes over time than something like your metabolomics or potentially even proteomics. But that could be another reason why we didn't really see that good of results from the PCA or random forest. And additionally, maybe if we were to reconduct this study or add in additional participants, it may be useful to look at more extreme altitude differences. So we only looked at a difference of 8,000 here. So maybe we need to look from 0 to 10, or they need to have longer exposures, longer time to see and develop those changes. And additionally, I think that some more work could be done with looking at the log2 fold change values, but there wasn't enough here. And kind of moving forward, there may be some more information that's gathered there, potentially looking at like the variable importance with those to see if that was the same or different from just the raw variable importance, and just to see differences there, or to look at the lipids that we're showing within that one to see if those are potential lipids worth investigating further in further studies or doing some research to see what the significant lipids, like what part of biology they were relevant to, what processes they affected, etc., stuff like that, to see. So the kind of the overall thought here is if hypoxic environments for like pilots or other Air Force personnel that might be on these airplanes, if long-term hypoxic exposures can have, cognitive decline or significant changes to their body that can cause these long-term effects and different things like that. So potentially looking at, log 2 fold change could be could bring about a little bit more results, or looking at the 2 lipids that showed significance in those box plots may, be the point of study moving forward. So those could be potentially the lipids of interest that could be causing these cognitive changes. And with that, I would like to thank you all for watching. And if you have any questions, feel free to leave a comment below. Thank you for your time, and I hope you enjoyed my topic today. Thanks.